Feedback day. The feedback day. Remember, it was a feedback. Oh, it was a feedback day. Woo! Feedback day. Yeah! Welcome back to your feedback video. Nice cup of coffee this morning. Today's date is the 27th. No, today's date is the 28th. So this is the Desmos quiz that you completed yesterday. Thanks for the 12 folks that participated with this. Let's go ahead and just get started right away on question 1. The manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the beverage fountain instead of filling the cup with water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled the cup with a soft drink from the fountain. So they're filling up water cups with soda. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountains. We're going to construct and interpret a 95% confidence interval. First thing that I noticed right away, make sure you do the 4-step process. We will state, plan, do, and conclude. State, plan, do, conclude. Statistics problems demand consistency. So this is question 1, part A. We're going to construct and interpret a 95% confidence interval. State. So we wish to estimate the true proportion of customers who order water cups who actually fill the cups up with a soft drink at 95% confidence. All right. Yep. So stating that we want to make a 95% confidence interval for that true proportion. So we got our state, good to go. Let's plan it out. So we're going to check our conditions. So I'm going to make a statement here. So what we're going to be doing is checking our random condition. Do we have a random sample? Yes, it was stated. It was a random sample of 80 customers. Remember that the reason that we're checking these conditions is to construct the interval. We want to make sure this is an appropriate scenario to construct the interval. 10%. We want to make sure that we aren't taking more than 10% out of the total population. Now this one kind of threw me for a loop for a second because, we took 80 customers, and so that's 800 customers. Well, it seems reasonable that 800 customers would order in general, but I'm looking for 800 customers who order a water cup. That seemed kind of like on the fence for me when I was first looking at this. I was like, I don't know. I could see it one way. I could see it this way. The question did say construct and interpret. So I'm going to avoid saying I, and I'm going to say we will. We will assume that there are more than 800 customers who would order a water cup at this fast food restaurant. Which brings us to large counts. Just a quick reminder that the 10% lets us use the formula for the standard deviation of p hats. So that unlocks standard deviation. Large counts unlocks the assumption that we have an approximately normal sampling distribution. So keep that in mind. Large counts, we're looking for at least 10 successes and 10 failures within an expected sample. And that actually happened here. So 23 did fill with soft drink, which would imply that 57 did not fill with a soft drink. Both at least 10. So we're good to go. So we've done our state, our plan. Now it's time to do the do. A few things to think about here. I'm going to put our p hat, our sample proportion value is 23 out of 80, which is equal to 0.28 0.75. We have a sample size of 80. So I'm going to show you what it would look like to do it by hand, but then also some calculator work as well. So we'll do the first one will be by hand, second one by calculator. Remember that any confidence interval is some statistic plus or minus a critical value times a standard deviation of the statistic. So you certainly do not need to write this, but these are just a few reminders, considering this is a review of the AP test. So this isn't actually in your formula sheet. It's right here. If you forgot what a margin of error is, this whole thing right here is a margin of error. So the plus or minus. Okay, so our statistic. Our statistic is our value or is the sample proportion. So we have 0.2875 plus or minus a critical value. The critical value is found by looking at our confidence level. Our confidence level is 95%. So two options, 95%, you could just remember that that's 1.96. Since it's a z-score, how do we know it's a z-score? Easy peasy. Easy peasy. If you forgot, you could always look at your infinite t-score value, which is down here. So our infinite t-score value, here's 95%, is 1.96 right there. So you can look at the bottom. Now our standard deviation of the statistic, our statistic is p hat. And so in our formula sheet, for a sample proportion, here's the standard deviation. So the square root of p times 1 minus p over n. So we'll have the square root of our proportion times the complement. And so when you're doing it by hand, this is one thing that you would need to have. You'd have it all set up and ready to go. Then you can go to your calculator and evaluate the rest. And so if we evaluate this in our calculator, we would get this interval approximately. Let me show you what it would look like on a calculator as well. So this is by hand. The big thing with by calculator is that you need to state the name of the test. So the first thing is you would have to say 1 sample z interval. If you said test, that would be incorrect. So 1 sample z interval, and if we if we go to stat, go over to tests, all these things are tests, and eventually you get down here. So it's not a z interval. So 1 proportion z interval. So what you're going to have to do is the x is the number of observations. In our case, it's 23. Our n value is 80. Confidence level, and there it is. There was some rounding with mine, but as long as you're in the ballpark, that's going to be okay. So you're going to have to state your p hat, sample size, and then your interval. So the calculator gave me slightly different, but as long as you're in the ballpark, you are going to be fine. It's way less work, but I would say that this is going to be more helpful in the long run than this. I'm going to be using this one for my interpretation, just heads up. So that is our do. Let's go ahead and conclude. Okay, this is an interpretation of an interval. Some people just put the interpretation as their solution. Make sure that you do the 4-step process in order to get full points on constructing an interval. We are 95% confident that the interval from 0.1888 to 0.3862 captures the true proportion of customers that order a water cup will actually fill the cup up with. Awesome. Here we go, question 1, part B. The manager estimates that each member who asks for a water cup that fills with a soft drink costs the restaurants a quarter. Suppose that in the month of June, 3,000 customers ask for a water cup when placing an order. Use the confidence interval constructed in part A to give an interval estimate for the cost for the restaurant of the month of June for the customers who ask for a water cup to fill. Okay, so essentially we're going to make an interval for how much money they're losing. How much is it costing them per month for the month of June approximately, if everyone's doing this. So you guys had some really nice responses, pretty clear. The first thing I noticed was this. So I'm going to reference my interval. So here's my interval again from the previous problem. And so this is trying to capture the true proportion of people who do this. Well, if 3,000 people come in, and we're trying to find the proportion of people at the restaurant, well then what I would suggest is just take these proportions and find these proportions of 3,000. So we'll take 0.18832, we'll times that by 3,000, and then we'll take 0.3862 and times that by 3,000. What this is going to do is convert it into people who would do this. Cool. And so now I have a slightly different interval. This is not my answer, by the way. This is the number of people out of 3,000 who I would expect to do this horrific act. And so if it costs them 25 cents, then we'll take each of these numbers and times it by the cost. And so this would equal, looks like 141.25, and this would equal 90. So our interval, now this one actually just says construct the interval. And so here's the interval. You don't have to interpret it. Keep that in mind. So if it doesn't say interpret, you do not have to interpret. But this is the interval for the cost, the approximate cost out of 3,000 people that it's going to cost this fast food restaurant. Most likely losing at least $140. At most, like no more than 300, but still, that seems every month. I'm not okay with that. As a restaurant owner, I'm not okay. I don't like this. So this is question 2. I'll do this. It's a little bit easier if I just kind of show the picture here. The chemicals in clay used to make pottery can differ depending on the geographical region where the clay originated. Sometimes archaeologists use a chemical analysis of clay to help identify where a piece of pottery originated. Such an analysis measures the amount of a chemical in the clay as a percent of the total weight of the piece of pottery. The box plots on the left summarize analyses done for 3 chemicals X, Y, and Z on pieces of pottery that originated in one of the 3 sites, 1, 2, or 3. For chemical Z, describe how the percents found in the pieces of pottery are similar and how are they different among the 3 sites. I'm not going to put like a model solution here per se, because there's a lot of right ways to answer this question, but I will kind of point out the things that you should be saying, that you should be describing. So here's chemical Z, and chemical Z. So whenever you describe or compare distributions, you put your socks on. So shape, center, spread, outliers. So we're going to do that with Z. So similarities and differences. So the similarities that they have is that here's Z, Z, and Z. There's one big similarity that I'm noticing right now, and is that they are all symmetrical. So Z is symmetrical. This one is tighter, but it's symmetrical, and this is symmetrical as well. So their shape, they have symmetry. Okay, do not say approximately normal because we do not know if they're normal with a box and whisker, but say that they're symmetrical. Another similarity that they have is that their centers are all approximately equivalent. So they have similar centers. Their medians are all approximately the same as well. So they have similar shape and similar center. However, their spreads are the thing that differ the most. So site 3 has a much larger spread compared to site 2, and site 2 certainly has the smallest spread compared to the other 2. So make sure you use descriptive words like larger than, greater than, and compare it a few times. Make sure you for sure have your shape, that you've compared your shape, center, and spread. Consider a piece of pottery known to have originated at one of these sites. The actual site is unknown. Suppose an analysis of the clay reveals that the sum of the percents of the 3 chemicals is 20.5. Based on the box plots, which site 1, 2, or 3 is the most likely? So, okay, this one took me like a second or two to kind of understand what it's talking about, but so we have, this is site 1. All 3 of these are site 1. All 3 of these is site 2, and all 3 of these is site 3. So we're checking to see when we add up all of the sites, which one gets the closest to 20.5. I used the medians because pretty much every single box and whisker here is symmetric. So the median would be your best choice or your best guess to what the actual percent is for each of the chemicals. So for example, for this one, I added 7 plus 13 plus 7. And when you add up these, if I add up these medians, I'd get 27%. So that's much above 20%. So that's probably not the site. I did site 2, so I added 7 plus 6 plus 3, and I got 16. Well, I mean, it's closer to this, but I was curious to see about this one here. So for this one, I added 6 plus 7, and I got 20%. So when I add up the medians for this one, it's 20%. That's the closest one. So based off the box plots, when I add the sum of the medians here, it's most likely going to be at site 3. So I justified my choice by talking about the addition of the medians, and I chose the medians because it's symmetric. So site 3 would be the best when you add up all of the approximate percents. Next question. Suppose only one chemical could be analyzed in the piece of pottery. Which chemical X, Y, or Z would the most useful in identifying the site where the pieces of pottery originated? So which chemical would probably be the best for saying like, okay, so for example, like let's say that chemical X shows 7%. Okay, well here's X, and here's X, and here's X. Well, if you notice, X has 7% here. It could have 7% here, and it certainly could have 7% here. Let's say that okay, so chemical X kind of stays this, like it seems like I mean, it's highest here, it's lower here, it's low here, but with the big outliers. So let me ask like a similar question with chemical Y. Let's say that chemical Y produced a percent of like 11%. Here's chemical Y. This probably did not produce 11%. This probably did not produce 11%. This one probably did. So I can be pretty sure that if chemical Y produced 11%, it's that chemical or that pottery probably is from site 1. What about if the chemical Y produced like, 3%? Well, then I have no idea if it's site 1, because none of these are really going to do it. But if it was 3%, chemical Y is certainly going to be saying that it's at site 2 with some pretty big confidence. And this one, it'd be really rare for chemical Y to show 3%. So notice how chemical Y is the standout at site 1, and it's the standout at site 2. And in site 3, it's not the standout, but in a way, if you saw that chemical Y was at 7%, well, then it's probably not site 2, and it's probably not site 1. It's probably going to be at site 3. So chemical Y is going to be the best one. Z is much too varied, and it also has the same center the entire time. So like, for example, if I said it was at 9%, right? So like around here, well, I'm not really too sure if it's coming from site 3 or 1, because they both have 9% in the whisker of their box plot. So Y is the best chemical. It's like the most defining chemical percent. I'm pretty confident, especially if it's kind of like around here. Well, then that's pretty true, because all the other ones are going to produce site 3 as well. So Y is the most defining one because it has a little outlier, not an outlier, but it is very vulnerable here, or it's very defining here. So chemical Y is very defining for site 2. It's very defining for site 1, and it behaves fairly similar to all the other ones at site 3, which is helpful. All right, so I'll anonymize here, and let's take a look at the silly question. So hope you have a good rest of your day. Thanks for watching. This has been free response questions practice. So we'll be doing another one of these the next few days. Oh, I'm tired. All right. I'll see you folks later. Take care now. Bye-bye then.